sketch the graph of f based on the information that we have about f prime. So we can start, for example, with the fact that this is a local minimum. We don't know the value of f at that point, but I'm just going to put it anywhere. That's a local minimum, so it's looking like this. It has concavity up. And the next interesting point that we talked about was this one. A turning point of f prime is an inflection point of f. Concavity was up, so when it reaches here, it has to be concavity down. I'm going to put a tangent line at the inflection point in my picture. I always like to do that because it really highlights the fact that that is the inflection point, because the tangent line at the inflection point looks really specific. It's crossing the function. So I like to include that in my sketches. And here the next interesting point that we're going to see is 0. 0 is a local maximum of f because it is this type of 0 in f prime going from plus to minus. So my function has to keep going up until 0. Then it's going to have a turning point. R is going to be an inflection point of f because it is a turning point of f prime. So I have to be a little more careful how I draw the function around here because you have to be able to see the concavity change. Down, and here I am going to change it to concavity up. I'm going to put a tangent line in the sketch for the same reasons that I was just saying, just to highlight the inflection point. And the next interesting point here is t. T is also an inflection point because it is also a local maximum of f prime. But at the same time, f prime is 0 here, okay? T is also an x-intercept of f prime. So this has to be both an inflection point and a stationary point. It's one of those horizontal inflection points, so I have to draw it even more carefully because it needs to look horizontal. And let's put the tangent line over there. So yeah, this is the graph of f.